Hello everyone, this is Sudhir and welcome back to our maths class. Today I am going to teach you Theorem 9.1 and 9.2 from the Tangent to the Circle chapter. Okay, so Theorem 9.1 and 9.2, the both are very important theorem for the board exam. So what is the first theorem here? The tangents at any point of a circle is perpendicular to the radius through the point of contact. So in the last class we have discussed the radius and tangents makes 90 degrees at the point of contact. So that is the statement here. Okay. So how we can do it? For suppose it's a circle. Okay. So the center we are taking as O XY is the tangent and the point of contact we are taking as P. This is the radius. OP is the radius. Now for suppose, if it is not a 90 degrees, so this theorem how we can prove? That is the method of contradiction. That means we can take first if it is not a possible, then we can search for any other alternate solution. If you didn't get, if you won't get the solution, so how we can prove this one? For suppose if OP is not a perpendicular to XY, there is a line which is perpendicular to XY. Okay, so that line we can take here. Maybe it is Q is a point I am taking on XY. So here I am taking one more line. Okay, so before going to discuss this one, we will discuss one important point. Here we have a point. Okay, so some students are standing here, so I have given a target point A, B, C, D, E, F, G, H, some different points. This is the point O. Okay, so some students are standing here, so I have given the target. So for example, student 1 should go to this point and should touch the point and should come back again like this. Got it? And student number 2 should go and touch the point D and he should come back again. Similarly, student number 3. Okay, so and student number 4, student number 5. The student number 5 is just I am taking a perpendicular line, straight. So the boundary line is there, this one. This is the boundary line, XY. On XY we have some different points. For example, I am standing here. So the boundary line is there. Okay, so just I am sending one student. So one student went this side, another student is went this side, one student is went straight. Okay, so at a time these all students are went. Okay, so at the time these all student has to go and they should touch these all the points and should come back again. Okay, then do you know which student will win the game here? Some student number here 1, 2, 3, 4, 5, 6, 7, 8. 8 students are there. So 8 students, just I send the 8 students from one fixed point here. So I have given the target to student number 1. He should touch the point A and he should come back. The point A is there this corner and the point H is there in this corner and point E is there the strike. Okay, so I have given the target then to touch and just again come back. So which student can win the game here? Exactly, student number 5, because this is the shortest distance here. This is the shortest distance than the remaining all cases. Okay, because only here XY is a straight line we have taken. On the straight line, the perpendicular line is there. The perpendicular line only is the shortest line than the other. Got it? So, and one more, you know very well, if you can take these all are the right triangle, these all are the right triangle. In a right angle, hypotenuse is the longest side, so that these all are the longest. Got it? So this one is the shortest side here. So the same logic, I am going to apply here. Just keep it in your mind this game concept. Okay. Now I am going to take now. If it is not a 90 degrees, so we have a somewhere is a 90 degrees. The point if I take here Q, while Q I have taken the outside. If I take Q on a circle, okay, on a circle just I am taking a point like R. This is OR is the radius. OP also a radius. This OP and OR both are same. If I take the Q is a point on the circle, then if I draw a line, it become what? Yes, it is a secant, but we have to take a tangent. So Q is a point I have taken on xy. Now step by step we discuss. Given what we can write? Let O center of a circle and xy is a tangent. Got it? Next step, RP required to prove. What we prove? OP is perpendicular to, and what is OP here? It is a radius. Okay, and OP is a radius. OP is a radius. Now OP is perpendicular to xy. This one we should prove. Okay, so prove. How we can prove? Let us assume that OP is not perpendicular to xy. OP is not perpendicular to xy. So let a point Q on xy. Let a point Q on xy. Xy is a tangent. Okay. So let a point Q on xy. That means which is perpendicular to which is perpendicular to xy. So now what we do here? Just you can compare this. We are comparing with OP and OQ. Take your OQ. What is the radius here? What's the radius? OP and OR is the radius. Now I am going to take here OR is equal to OP. Okay. So R is a point on a circle. Both are equal because of the radius. But now I am going to add here OQ. This OQ is more than this OQ, because OR is equal to OP, but OQ means definitely it is more than OP. Got it? OQ length is more than OP. Now, over. Then if I take any point here, like okay, Q dash or something like a different point I'm taking, like maybe A, like here B. So if I take these all the points, so these all points are all lines are more than OP. Got it? For example, A is a point I have taken here. Now OA is definitely more than OP, and OB I have taken this OB also more than OP. So finally then what we have written here, OQ is more than OP. So this is, that means OQ means here this line and this is the OP. So already I said that means comparing any other lines. So OP is a shortest straight line. OP is the shortest line or shortest distance from O. OP is the shortest distance from O. Comparing any other, just I have taken OQ and comparing with OP. So OQ is more than OP. So comparing with any other lines like A, B, OA or OB. Okay, if you take any point on XY, okay, these all the points are definitely more than OP. So what we have discussed here, what we proved, OP is the shortest distance from O. Okay, now let me know here which is the shortest distance from among these all. OE. Means what we have discussed here before enter the problem. What we have discussed about this, OE is the shortest distance on XY, right? So the shortest distance means what is that? Perpendicular. The perpendicular line on XY is the shortest distance. The perpendicular line on XY is the shortest distance. So OA is perpendicular to XY. Got it? So here the shortest distance is OE because we have the perpendicular line. So that we can say here OE is perpendicular to XY. So same logic here. When OP is the shortest distance from O, therefore OP is perpendicular to XY. So finally what we prove? OP is perpendicular to XY. That means OP can form here 90 degrees. Now OP can form here 90 degrees. So what we can conclude here? OP is a line, that means a radius. The radius makes 90 degrees at the point of contact. Okay, so this is the theorem here, the very important theorem it is. So actually This one you don't need to write for your understanding. Just I explain here. Just keep it in your mind. The shortest distance from the when you have a line like a boundary. So what is shortest distance here? The perpendicular line. The perpendicular line to this boundary line is the shortest distance. So the shortest distance is here OP. So finally here we are proving that OP is the shortest distance among the other. Okay, on XY line. Okay, so OP is the shortest distance, means that OP is perpendicular to XY. So this is our proof. So I hope you understood this concept. So next theorem is the theorem number 2, 9.2. It's the most important theorem for 4 mark questions. Let us discuss. The next theorem is the length of the tangents are drawn from external point to the circles are equal. In the last class we have discussed it is one of the important concept it is. So how it is? So one more time we will discuss now. That is the length of the tangents drawn from an external point to the circles are equal. So now I am going to take a circle. Yes, it's a circle with center O. Okay, O is the center of the circle. Now, if I take a point which is external to the circle, that point is P. From P we are taking two tangents here. Means on the circle, two tangents we are drawing here. So don't forget while you are drawing, just it should be touch the point here. This is the point A and this is the point B. This OA, you take the point is here. So OA and OB are the radius of a circle. And here it makes the 90 degrees. So OA and OB makes with the tangents of 90 degrees, right? So this is the figure, rough figure, and here we are joining this OP also. Now what we have to do? PA equal to PB. How? Just given. What is given here? What is given? Yes, that is O is the center of the circle. Center of the circle. Okay. OA, comma OB are radius. And OA is perpendicular to PA and OB also perpendicular to PP, right? So O is the center of the circle. We have taken that O is the center of the circle and OA, OB are the radius. Okay, so P is the external point, right? What is P and PB here? Tangents. P and PB are tangents of the circle. Okay, so these are the points we have taken. Next, RT2 required to prove. What we have to prove? This PA is equal to PB distance. PA equal to PB. Prove. How can you prove? Now, I am going to compare the two triangles, triangle OAP and OBP. So, in triangle OAP and triangle OBP, now we can compare here OA equal to, this OA is equal to OB. The reason, since radius, these are the radius, okay. So, radius of the circles are equal. Next, OP equal to OP. OP is the common side of the both triangles here, okay. OP is the OP since it is common side. Now, angle OAP equal angle OB. OAP, this is 90 degrees, OBP also 90 degrees, is equal to 90 degrees. The reason, what the reasons we can write? Radius and tangents. Radius and tangents makes right angle at point of contact. Okay, so next, so we proved that radius means side equal. OP, do you know what is OP here in this triangle? OAP or OBP is the right triangle. In this right triangle opposite side is called the hypotenuse, right? So observe here, sides are equal, hypotenuse equal, right angles are equal. So now the two triangles are the congruent. Which two triangles? Triangle OAP is congruent to triangle OBP. How these two are equal? Since RHS congruence. These are the RHS congruences. So right angle, OAP, OBP is right angle, and hypotenuse, OP and OP both are common side we have taken. It is a hypotenuse. This is a hypotenuse of a right triangle, because in the right angle opposite side is called a hypotenuse, right? And the next point is sides, OA and OB are the radius. So radius of the circle, so that those are the equal. But this OA and OB are the one of the sides of these two triangles. So right angle, hypotenuse, sides are equal, so that the two triangles are the congruent. Now what we can write here, PA is equal to PB we can write. Now when the two triangles are the congruent, from CPCT means corresponding parts of congruent triangle. From CPCT we can say the remaining parts. Remaining parts means what? These two angles also equal. Here these two angles also equal. Now these two sides also equal. So remember these points, children, very important. So based on these points, in the next class we will solve some important problems. So these two triangles are the congruent, so that these angle here what the angles are making, these two angles are equal. These two angles also equal. Just keep it in your mind. It is okay. Equal means if this line will be bisect this angle to two equal half. For example, here you have 100 degrees, it will take 50 and 50 degrees. And here if you have 80 degrees, and it will be divided 40 and 40 degrees. Okay. So 50, 40, 90 over sum of the three angles of a triangle is 180 degrees, right? So see, sum of these two angles, one more important point here, sum of these two angles are supplementary, don't forget it. So sum of these two angles, by adding the both angles here, you will get 180 degrees, because OAPB is a quadrilateral. Quadrilateral means sum of the four angles are equal to 360 degrees. And here 90, this one also 90 degrees. So sum of these two angles are 180 degrees. Then the remaining two angles also, sum of the remaining two angles also will get 180 degrees. That called supplementary angle. So that sum of these two angles are 180 degrees. And this line can bisect the angle into two equal halves, because of it is a congruent triangle. So don't forget this point, it's a very important point. But now in this question, in this theorem, we have to prove this point. We proved it. One more time, we can recall how it is. Circle, O is the center, P is the external point. So we have drawn the tangents here, PA and PB, and these are the radius. Radius are equal. OP is the common side of the both triangle, and this OP is called the hypotenuse of a right triangle OAP and right triangle OBP also. And here angle A and angle B both are 90 degrees, because the radius and the tangents makes 90 degrees at the point of contact. Point of contact means A and B are the point of contact here. Okay. So the two triangles are the congruent, because of it is RHS congruency. Right angle we proved, hypotenuse we proved, side we proved. According to RHS congruency, the two triangles are the congruent. So we can say here PA is equal to PB. The reason is CPCT, corresponding parts of congruent triangle. So this is the proof. So I hope you understood today these two theorems are very important theorems. So practice very well. Okay. So make sure it is very important for the public examination, these two theorems. Okay. So I hope you understood today's concept, and you enjoyed the today concept also. So take care. Bye. Jai Hind.